Welcome to one and all to the second session of Unit 4 on construction of CNC machines in computer integrated manufacturing. Dear students, let us see the different types of loads that is to be considered in CNC machines. The first kind of load in the last class we discussed is a static load. So what is static load? It is a load on a machine structure due to its own weight and weight of slides, jobs and other attachments. So you can see there is a structure here. The weight of this material will lie on the machine structure. So this type of load we will call it as static load. So here these load are induced when the machine is in stationary. So this is very important. The first design consideration in any CNC machine should be based on static load. It also includes some of the cutting forces during cutting operation. The static load, while designing static load, we have to consider some percentage of the cutting forces that is acting during the cutting operations. So this is very important on this. So the machine has to withstand the own weight. Once it withstands the own weight, the design is safe. Then the CNC machine is safe for starting the operations, or it is ready for manufacturing. So the second kind of load is dynamic load. So the dynamic load will appear during the moving of machines due to very high cutting speed, feed, depth of cut, and also the acceleration and retardation of moving parts. Acceleration and retardation of moving parts. So dynamic loads will appear during the moving of the machine due to high cutting speed and feed. When you increase the cutting speed and feed depth of cut, so ultimately the vibrations are caused. These vibrations has to be withstand by the machine. So the vibration factors should be considered in dynamic loads. Not only vibrations, due to machines they are subjected to fluctuation and variable loads. So when it is subjected to fluctuation and varying load, so it's also a kind of a vibration. This dynamic load has to be withstand by the any CNC machines. So important aspects. Next is, so dynamic load, the machine structure should have high capacity to withstand these loads, otherwise the whole machine starts. So what does it mean? So it has to be designed in such a way that when it is subjected to very high speed, so depending upon the very high capacity, it has to withstand the loads. The following are some of the causes of vibration. When the cutting speed and feed increases, there are certain reasons those causes the vibration. One is unbalanced rotating parts. When the parts are moving, so due to unbalance, so what happens? The wear and tears are caused. This results in a vibrations. So the moving parts causes a vibrations. So this load has to be considered in dynamic load. Improper meshing of gear, that is backslash error, we can call it as. Backlash error means, so it is a kind of an improper movement, means I can call jerky motions while engaging and disengaging of a gear. There is no smooth functionings of it. Why there is no smooth function? Because the machines are vibrating. So the vibration, if vibration is reduced, so automatically these backslash errors can be eliminated and the machine runs smoothly. Bearing misalignment, very important. The bearing is the rotating part of any CNC machines, so it is continuously rotating. So what happens? The bearing misalignment, one bearing to another bearing, if there is any misalignment, so the vibrations are caused. The smooth functioning is not achieved. Interrupt cuts during the machining means, so first we have, suppose example, if I want to give 1 mm depth of cut, so every time when I give depth of cut, it should be 1 mm. What happens if I shift directly to 2 mm? So if you are skipping one intermittent step, directly if you jump, what happens? The cutting speed is very high, depth of cut is very high, so then the vibrations are caused. So the major reasons I have put out there, there are a few more reasons in CNC machines. So few very important vital, it's a root causes of any vibrations is unbalanced rotating parts, improper meshing of backslash errors, bearing misalignment, and interrupts during the machining operation. These are some of the very important causes of vibrations. So these are some of the factors that has to be considered for dynamic vibrations. So what about the how to reduce this vibration. So these are some of the remedies that can reduce the vibrations. First one, reduce the mass of the structure. So what is going to do? Reduce the unwanted mass, not the entire mass. It is the unwanted metal. Where the unwanted metal is not required, there is no functions for it. Reduce it. So reduce the stress concentration factors at that area. So remove unwanted and functional parts in that. So reduce the mass of the structure is one area. Second one, increase the stiffness of the structure. What is stiffness? Resistance to deformation per unit length. So it is nothing but damping. Increase the cushioning effect. So if you increase the stiffness, it can withstand more vibrations. So if stiffness is directly related to the vibrations, so it gives a very good cushioning effect. It will withstand the vibrations, and that vibrations is not transferred to the machine structure. So it increases the stiffness of the vibrations structures. Improve the damping properties. That damping is nothing but a cushioning property. Provide a proper springs, provides a proper belts. So in order to perform that, so leaf plates are there. Today very important is the cushioning effects. If you give good cushioning effects, so vibrations are avoided. So those vibrations are not transferred to the machine structure. And these are some of the ways to reduce the vibrations. So next topic is thermal load, very important. So major thing is that, so the thermal loads are the thermal distortion of a machine structure due to local heat sources. What happens in CNC machines? All the motors will be fixed inside the structure. So what happens? The motor will produce enough number of heat. This heat is not able to dissipate, and cutting forces will generate any high number of heat, and this heat is not dissipated. So this local heat is going to cause a distortion in a machine structure. So they cause thermal gradient, temperature difference in a machine structure, and also causes deformation of various machine parts. So what happens due to this heat, when the temperature is very high, because you can see the cutting speed is very high, depth of cut is very high, enormous amount of heat is generated, temperature will increase drastically. Once temperature increases very high, so due to this heat, the metal, whatever it may be a fixture, it may be a cutting tool, it may be any moving parts. So the workpiece itself, it may expand. Due to expansion of what happens, the required accuracy will not be achieved. So that is why the heat has to be dissipated in a proper way. So this is very important. So third cause for any structure of CNC machines is a thermal load. So you should keep very good eye contact on this particular thermal load while designing. So the following are the sources of heats in machine. In the last class, in this session we saw on the last slide what are the causes for vibrations. So let us see what are the causes for heat source. Electric motors means electric motors are one factors which causing the heat. When they are mounted inside the machines, then they result in a heat. Friction in moving parts, mechanical drive and gearboxes. These gears and drive box while engaging and disengaging produce enormous amount of heat due to friction. So this heat is one of the sources of heat in machines. Friction in bearing and guideways. The bearings and the guideways, when they are moving, so the heat is generated. During machining operation, the chips are produced. During chips, what happens? The very high amount of heat is produced. So these heats will cause this type of thing. Environmental temperature, very important. The surrounding temperature is very high. You say 30 to 40 degree. So then the entire machine has to be kept cool. Otherwise, this temperature has a significant effect on the machine tool, I can say. So this is all about your different types of loads. So dear students, in this class we discussed about 3 different types of loads. One is static, the weight of one machine itself. So second is dynamic. Dynamic is the weight due to moving parts, load due to moving parts, that is going to cause frictions and is going to cause vibrations in the machine tool. And thermal loads, the heat generation source, the heat has to be dissipated out thoroughly so that the thermal load should not be a problem. So dear students, at this time, thanks for your patience listening. At this slide, I am going to stop my second session of Unit 4. Thank you.